We'll just get rocking and rolling. We'll welcome everybody to our third Tech Talk that we started here at Steiner. And today we have a really interesting topic about microgrids. And we're lucky to have Billy Lowe, product sales manager from Schneider, with us today to kind of go over, I think, a very interesting topic and definitely an emerging trend in our industry, especially for our customers. So happy to have him with us today. Quick overview, Steiner Tech Talks, just trying to be a monthly series, enable us to connect with global experts such as yourself, Billy, and other topics. And it's a wide range from commercial construction, industrial and user OEM and metalworking. And we will have a recording link. It'll be shared on YouTube later from Steiner's page so that, if you want to rewind it, go back, look at it, and get more information later, that would be perfect. And then really it's designed to introduce a topic in 30 minutes. And then, as you think about it more and process it more, then we'll have further conversations down the road, or can reach out to us for more information. So with that, today we have, like I said earlier, we have Billy Lowe on the phone with Schneider Electric. He's the Microgrid channel and partner sales manager. So I'll let you introduce yourself, and then you can kind of go through the topics. I will say, as a note, if there are any questions that people have during the presentation, we will have a session at the end for Q&A. And please type your questions into the chat, and we will try to get to that at the end.
Cool. Thanks, Rob. Microgrids in 30 minutes, guys. This could be a whirlwind. It's a tough one. But no, thanks for having me, Rob, and everyone. Happy to be here. So appreciate the opportunity. I'll do a quick introduction, everyone. My name is Billy Lowe. I've been with Schneider for a little over 6 years now out of school, and a handful of different microgrid-related roles. So everything to date's been more on the technical and hands-on side, I would say. So commissioning projects, being a customer and quality support engineer. I was the guy who got the call when the battery tripped and had to remote in and help troubleshoot those types of things. And then also my last role before the one I'm in now, I led our team in our really cool microgrid test and validation lab up in Andover. So, and then just recently, beginning of July, kind of switch sides of the house, if you will, into the commercial and sales side of the world. So definitely not an expert on that side of the house yet. But like I said, I'm happy to be here, and we'll get going. So if you want to go to the next slide, Rob. Yep.
Quick overview, and I'll let you kind of dive into, I think I will say, rapidly changing landscape.
Yep. Yeah, and so just Rob's already kind of said this, everyone, but just going to do think of it as kind of like a microgrid 101 today. Try and give an overview of the value prop, kind of some common use cases, drivers for people wanting to implement microgrids, as well as what are some of those value the value that those sites and customers are looking to get out of their microgrid. So let me start here and kind of set the stage with what we refer to as the new energy landscape. So what I mean by that is really a kind of a fundamental shift and change, if you will, and how power and energy is generated and distributed and consumed as well. So traditionally, it's pretty simple, right, guys? We have a power energy provider. And then on the other end, we have a power energy consumer. We have the power plant and we have the customer on the end, right? And then there's some distribution and transmission in between, but it's a relatively simple chain of events, if you will, there. So just a couple more comments there. It's that centralized generation, typically what you think of as a normal power plant, right? There's one directional power flow. It's not going back and forth. It's from that producer to that consumer. And like I said, that consumer really being the end user or the customer, right? So it's a change from that historical value chain to a new one, an updated one, a refreshed one, if you will. which you can see down there at the bottom. So now in that centralized generation, we still have that, but it's not just your typical power plant anymore. That could be utility scale solar involved as well, big wind turbines as well. You still have that transmission and that distribution, but then when you get to the end of that chain, if you will, there's not just an energy or power consumer anymore, right? There's actually the producers too. What you'll hear a term called a prosumer, a producer and a consumer. So think of really where how that comes into play is those on-site power sources, whether it's solar, a battery energy storage system, a windmill, a fuel cell, generators, even all of those on-site generating assets can produce electricity. And that electricity now also can flow in both directions, right? It's a common use case where people will reuse their on-site generating assets. And will actually push power back out to the grid. And sometimes if you have a good utility tariff, you can even get money off your bill for that, right? So that term for what we call on-site power producing assets, guys, you'll hear that referred to as a DER, or a distributed energy resource. So really anything that can make power and electricity at a facility or a customer site that's not coming from the utility. So solar, battery, fuel cell, windmills, generators as well, combined heat and power systems. All of those are what we'll refer to as on-site generation or distributed energy resources. And like I said, power is not just one directional now, it's bi-directional. It can flow both ways, right? So I think that's all I wanted to say here. If you want to go to the next slide for me.
Yeah,
Rob.
and I think as we learn more, as this market emerges more, I mean, I like that the traditional, like you said, it's just one flow. Everybody always views electricity as just a cost or an expense. And now in some cases, it could be a mitigation of cost and or revenue generation for them as well. And so it just kind of how you consume your energy and how you produce your energy is not like the game is starting to completely
it's not as
change.
simple anymore, right?
Yeah,
There's a lot more to it. There's a lot more variables. It's just it's more complex. Exactly. Yep.
And so, I guess the purpose of this is how do we navigate it and how do we figure out the best solution? So,
yep.
Good topic.
So let's talk about some of the key drivers, if you will, guys, for on-site generation and microgrids, which I'll get to more of a formal definition of a microgrid here in a sec, so just bear with me. But in general, why are people wanting to put these on-site power sources at their facility, right? One, high uptime requirements for critical infrastructure. So the analogy or metaphor, if you will, that I always kind of like to throw out here is think of yourself as like a manufacturing facility producing semiconductors, right, and chips. Well, for literally every second that those conveyor belts and those machines aren't running and pumping out chips, it's just astronomical dollars that business is losing, right? And you can make the same analogy in comparison with like the grocery store, even your local grocery store, right? If there's a utility outage and there's nothing else to provide backup power at that site, then they have to throw away everything in the freezers, everything in the deli, the meat department, and it's a big loss of money and dollars, right? So the resiliency portion is a key driver, and by resiliency, think backup power, right? That's what I'm referring to there when I say resiliency. The cost optimization and the economic side of things is also obviously a big driver. And those two things, resiliency and cost optimization and financial savings, can oftentimes be intertwined a lot. But for example, what I mean here is using those on-site generation assets to offset the amount of power you have to pay, you have to take from the utility, and what you're being charged for that, right? So for every kilowatt and kilowatt hour that you can produce on site, that's one less that you have to pay for at the end of the month, right? And why I said those two things are oftentimes you'll hear people think of them as like two distinct, separate market drivers, which they kind of are, but they're oftentimes intertwined, right? For example, that last example I gave about a semiconductor facility, having backup power to keep the lines running. Yes, that is resiliency, but it's also cost savings. There's financial impacts to that. Resiliency oftentimes is very closely intertwined with the financial side of a project as well too. And then lastly, sustainability as well too. Whether that's company sustainability targets being kind of pushed from the top down, if you will, government mandates, or just facilities, businesses, industries wanting to do better, right? Lower our carbon footprint, and so forth. So the three kind of the three things that'll make a microgrid happen, if you will, are the resiliency piece, the cost optimization, and sustainability. Those are the things that kind of get people to the table in those early stages of a microgrid project. I'll pause there and I'm ready for the next slide, Rob. I'm not sure if there's anything you wanted to add there.
Yeah, I mean, I think traditionally, when you think about the resilient side, I always put like three-phase UPS systems on it and with a backup generator, and that just seemed to be a good solution, an effective solution. Pros and cons to both. I'm not saying it's a bad solution.
And that is, it's a very valid point, and we have that conversation almost on a weekly basis of, hey, why make this more complex than it needs to be with all these fancy controls and all this stuff? When in this scenario, maybe all we need is an ATS and a generator and a UPS on a few key critical loads, right? So, yep.
But I think what's changing the conversation, maybe we get into, is now that power companies are changing the rates based on overall demand and timing. Before it was, you knew it was a cost per kilowatt hour, and now all of a sudden your cost per kilowatt hours depends on when you're consuming an electricity. So,
yep.
Like that previous model is just not as adaptive to the change in how you're being charged your cost for electricity. So,
yep.
I think this now gives customers a lot more flexibility, if you will.
Yep, 100%. And just to kind of give an example there too on the utility side of things. So if you happen to live in for California, for example, guys, your utility is more than likely going to be PG&E for a lot of the state, or some others as well too. But you're almost guaranteed to have one portion of your utility bill and your tariff being what's called the time of use portion of that, which is what Rob was alluding to, where you'll have a on-peak period of the day where electricity is going to cost the most. You might have a mid-peak period and you might have an off-peak period. So your off-peak period, where you might pay 10 cents a kilowatt hour for your electricity, is going to be maybe from like midnight to 6 a.m. And then you might have a mid-peak period at 6 a.m. to 10 a.m. When people are waking up, starting to use their hair dryers, things like that, turn the TV on, their microwaves, all that stuff, where you might pay 15 or 17 cents a kilowatt hour. And then you fast forward to the afternoon, you're almost guaranteed to have an on-peak period from about 4 or 5 to about 8 or 9 p.m. at night. So during that period of time, your cost per kilowatt hour can literally, guys, go from 10 cents a kilowatt hour to like 45 cents a kilowatt hour. So think of the scenario where you have a Tesla at home and you need to charge your EV for the next day. If you're going to be plugging in at that on-peak period and charging your EV there, you're really going to feel it at the end of the month when you get your utility bill. It's going to be quite expensive. So just kind of building off what you were saying, Rob, that's a good concrete example of where microgrids and on-site generation come into play from that cost savings and financial side of the house.
Yep. Well, moving on, kind of give an overview here.
Yep. And then here, so what is a microgrid now, guys? So the Department of Energy has their definition, what you're kind of see up there in the blue, and they define it as a group of interconnected loads and distributed energy resources within clearly defined electrical boundaries that act as a single controllable entity with respect to the grid. A microgrid can connect and disconnect from the grid to enable it to operate in both grid connected and island mode. So that was a mouthful. That was word for word. If you go Google it, how the Department of Energy defines it, right? What it is in simple terms, it's a small local power system. It produces, stores, and distributes power and electricity for a specific area or a facility, like a hospital or a college campus or a local grocery store or your Chick-fil-A down the street, a retail shop, things like that. And it can connect to the main grid, but it can also disconnect from the main grid and power that facility, keep the lights on and running when there's a utility outage or the grid goes down. So it's simply it's a local grid. It's a smaller grid that can operate grid connected when the utility's there, or when the utility goes down, it can recognize the utility went down and transition off grid, or what you'll often hear referred to as islanding or island mode, which is you are forming your own local power grid and power island, if you will, right? So it's a combination of those on-site generation assets. Mainly, you'll hear the most of a battery, PV, and generator, right? And then when the grid goes down, like I said, those assets will be used sometimes one at a time, sometimes all three together. It depends on the sequence of operations and the scenario. But those assets will be orchestrated, if you will, by a microgrid controller that's going to manage those assets and the loads of the building. And it's going to make some smart decisions to keep the customer's facilities lights on, their critical loads up and going, and so forth. So that's at a high level, simply what a microgrid is. And it's not really at a high level. That is what it is. You'll hear different definitions. If you talk to 100 people, you might get 100 different definitions of what exactly it is. But that's, in simple terms, it's a local power grid, operates grid connected or islanded. So you want to go to the next slide for me, Rob? And all I really wanted to show here, guys, is just some sizing comparisons. There's no hard and fast rule when you'll hear about like a small microgrid or medium microgrid versus a large versus utility scale. Here, mainly just kind of want to, there's no guardrails, if you will, but there's kind of some general ballpark. So when you hear a small to medium microgrid site or project, it's usually about 50 kilowatts to 3 megawatts, which is a pretty big range still, right? And those power values, usually those are referring to the size of the on-site generating assets, those DERs. So if you have a 500 kilowatt battery energy storage system and 250 kilowatts of solar panels at your facility, that would be like 750 kilowatts. That's what that number is referring to. So those are your kind of small to medium sizes. Like I said, think about shopping centers, hospitals, a Chick-fil-A again, your local library, those types of facilities. And then you get into your large microgrids, which could be a big hospital campus. It could be Northwestern University in Chicago. It could be a multiple city blocks, right? So just to kind of give you some points of reference, like I said, there's no set guardrails there. It's more just kind of guidelines, but that should give you kind of an idea of the small, medium size versus what we're talking about when we talk about a large microgrid, okay?
Okay.
And then if you'll go to the next slide for me, Rob. So there's really 3 types of microgrids, guys, or architectures at the highest level. And I'll explain why I said there's really 3 here in a sec. So you'll have your grid tied microgrid. So you could just have at a facility a battery and some solar, and you can use those on-site generation assets while the grid's up to say, for example, to go back to that time of use tariff example from earlier, where electricity might be cheaper in the morning and way more expensive in the afternoon and early evening. If it was a grid tied microgrid project, you would use that battery and solar, and you would essentially use those solar panels to capture that sunlight throughout the day, store it in your battery, and then when 4 p.m., 5 p.m. comes around, everyone's getting home from work, cranking their ACs, cooking dinner, you use that battery, use that energy that you store in your battery, and then discharge it, and you offset the amount of power you're having to draw from the utility when electricity is really expensive. But you would not, in a grid-tied microgrid, have the functionality or the capability to isolate yourself from the grid when it goes down, so you don't have that resiliency piece. In a grid-tied microgrid, all you have is that financial optimization piece of the picture. And why I said really earlier is because depending on who you ask in the DOE definition, if it can't isolate from the main grid, it's not a microgrid then, right? Some people, if they're being tough on how you define it, they might not consider that a microgrid. You just have some battery and solar. You don't have a microgrid in that case. That's one architecture. The other one would be an islandable architecture, which is that grid tied piece of the pie and the resiliency piece of the pie. So you have the ability to lower your cost of electricity, meet your sustainability targets by not having to pull all your power from the utility and using renewable on-site resources. And then you also get that other half of the pie where you have the resiliency piece. You have backup power to your facility, can keep everything functioning when the grid does go down. Oh crap, Rob, we're already at 11:22.
I know.
I'll speed up, sorry. And then lastly, you can have an off-grid microgrid, right? So think of a remote village near the Arctic Circle in Canada or northern Alaska, right? Where some places don't have a utility. So this village, their only option for power might be those assets that they have on site, right? So in that case, it's really just the resiliency picture because you're not paying a utility bill at the end of the month. There's nothing to financially optimize or to save money on and so forth. So those are kind of your three architectures, if you will.
And just do you see most of them grid tied, or is it just a nice balance between all three? Or
Islandable, Rob, I would say is the majority of the projects that I've seen and that Schneider deals with. Are islandable sites that bring both that financial optimization and cost savings when you're grid tied and the backup power for their facility because it's so and oftentimes that's the only way, not the only way, but you have to include both of those pieces of the pie in order for the projects to pencil out and get off the ground. So yeah, islandable sites would be the one that I would say is the majority of projects.
Okay. Oh, whoops. Sorry, went a little bit too fast there.
And I'll be quick here, guys. Just want to kind of point out some industry terms, if you will, that you'll hear a lot, and mainly the two levels of control here, and I'm referring to the energy management system and the power management system. So almost every microgrid control system, whether it's Schneider or the other big names, there's going to be two key pieces of that, which is the PMS and the EMS. The energy management system is really responsible for all of those grid tied things. Think energy management system, I'm in charge of saving money, making financially optimal decisions for this site. The second the grid goes down and it becomes a resiliency situation, that's where the power management system takes over and it's going to execute the sequence of operations, maybe some load shedding, switching back and forth between your on-site power sources like your generator and your battery. Your power management system takes over and is in charge when you need to keep the lights on. So energy management system grid tied. When you go to island, the power management system takes over and you'll have more or less those two control pieces in any project. Sometimes it might be one controller that implements both functionalities, or sometimes they might be two distinct different pieces of equipment and hardware. So just wanted to point out those control layers there.
Okay, makes sense.
I'll be quick here, guys, because we're running out of time, but I did want to put this slide and touch on it real quick because it gives you kind of that first step of oftentimes like how do projects even get started? What are people looking at? What information do I need to provide? All that type of stuff. So usually it's kind of bucketed into these three boxes here, which are we want to talk with the end user and the customer and figure out what their pain points are, what they're looking to resolve, and what made them even think about this as a possible solution to begin with. Are there sustainability targets? Is there an expected return on investment? Does this need to pay itself back in 10 years or 5 years or 15 years? The cost and impact of outages, for example, the semiconductor manufacturing facility, and then your resiliency needs as well too. So really just kind of having that first initial conversation and really being in listening mode, letting them explain to us what those issues are, taking them in, digesting them, being an active listener, and then helping them meet those, figure out a solution that's going to address those issues, right? Oftentimes the existing utility is a big impact as well too, especially with like new fast DC EV chargers. I've heard horror stories where people want to put in EV chargers, like level 3 chargers, and the utility's like, yeah, well, we're going to have to put in a new transformer. We'll get you on the waiting list. It's going to be $5 million, and we'll call you in 3 years when we get to you, right? That's not going to work oftentimes, right? So the situation with the existing utility, how much capacity they have available, is a big portion of it as well too. And then the infrastructure and the configuration. Are there existing DERs on site? Oftentimes you have people come to us, guys, where they have solar, they've heard the term microgrid, and they want to figure out basically, okay, if I get a battery to pair with my existing solar, what can I do with that combination now and so forth? So looking at what's already on site, the age and what shape that's equipment in, all that type of stuff. So we're really gathering a bunch of inputs. And then we will do what we'll call like a feasibility study or site assessment, where we might run some financial calculations with their 15-minute interval utility data, their utility tariffs, do they have the time of use, what's their demand charge. We'll do a feasibility analysis. Also looking at, are they trying to back up the entire facility for 2 hours? Or are there two really key critical loads that they can't live without, but everything else in the building they don't need? And how long do we want to have those loads powered for, right? So those types of things is what we'll look at in that feasibility study and that analysis. And then usually come up with a concept design, concept one line, and architecture, and then go from there. So that's kind of that first step, is that feasibility analysis and kind of site assessment.
And just on average, and I know each site is different and unique and special, but from your experience, you estimate a feasibility to take approximately how much time?
Oftentimes, Rob, just to be honest, the thing that takes the longest is oftentimes the representative of the customer, the end user, gathering those inputs that we need in order to do that analysis and that study. We have a lot of tools where we can take your 15-minute interval load data, plug in your cost per kilowatt hour at various times, and basically we get things spit out, right? But oftentimes, like, customers have never logged into their portal, don't know where to go to get that information. Maybe their equipment, their switchgear was installed 20 years ago. We'd like to see an overview of the existing facilities, infrastructure, electrical layout, and they have to go talk to 15 different people and herd cats to get it for us, right? So that's usually the thing that takes the longest and leads to it taking longer for us. But once we have all those inputs, and it's a week or two activity, sometimes a little more, sometimes a little less, but it's not anything crazy long.
Okay.
Let's skip this one for now, Rob, because we're coming up on time. Let me touch on this one real quick, guys. So one of the things that Schneider's really focusing on in our microgrid solutions and our offers and what we're trying to bring to the market is a more standardized approach. There was a saying that someone said to me when I first joined Schneider like 6 years ago, and they said something along the lines of, once you've seen a microgrid, you've seen one microgrid, because historically every single one has been so different. There's so many different variables in play in terms of the make and manufacturer of the DERs, the integration requirements. Everyone's different. That projects tend to take a while to commission and get off the ground. There's issues, there's strained relationships with the customers because schedules aren't being met and so forth. So one of our big efforts is, how do we bring standardization and microgrids to the masses, if you will, through a more configured to order approach, standardized, repeatable architecture, sequence of operations, controls, those types of things. And you'll hear, if you Google like Schneider microgrids, our kind of verbiage for that is what we call Microgrid Flex. That's our branding for this overall approach of standardization and repeatable microgrid solutions.
Okay. So yeah, again, it's an emerging market. It's a rapidly changing market over a period of
Exactly.
time, right? You kind of put together what solutions you had, but as more people get into it or different solutions, I think standardization across the board is just something you would just naturally see in any given market as it tends to mature.
Yep. And just one quick comment there too, Rob. One of the difficult things about microgrids in the US is kind of different than Europe, for example, is we have so many different local utilities and jurisdictions in the US that they could all have slightly different requirements. Some like PG&E basically will not put up with any other protection related than an SEL 751 versus another utility over here might like Schneider's or GP3. So all of the different utilities and what they like and don't like, their requirements, it can be a challenge in that standardization effort versus like in Europe, that's not the case. There's just a few big ones, right? So it's a little bit easier to take that standardization approach. But I've seen it just in the past 5 years continue to make progress slowly but surely. But I think that's the goal, right? Progress, not perfection, and so forth. So yep.
So seeing that we're over, what again, what kind of
Sorry.
is the big? No, it's good. I mean, a very interesting topic, but trying to fit all this information in a short period of time is difficult. But is there any like key takeaways, about things now that we've kind of given a definition, or what should people consider kind of moving forward, and what would be their first next steps?
Yeah, I would say that the first next steps, Rob, in terms of like trying to like identify a possible uh, microgrid site or what, just help me to help you with my answer.
Yeah, no, yeah, exactly. Like, okay, I'm thinking about it. It's an idea. Somebody put it out there in the next, somebody's strategic plan to figure out over the next 5 years, right? There
Yep,
may be some people in a little bit newer format based on,
yep,
scale, scope, but with it still being a bit of an emerging market, what would you recommend the first steps to
yep,
be in that?
yep. Gotcha. To put it simply, guys, I would recommend furthering your education on microgrids. We deal with well, let me pause there. I would say go and do some Googling, some good old fashioned learning, familiarize yourselves with the terms DER, islanding, off grid, battery energy storage system, being able to feel confident and comfortable and having that conversation, whether it's with an engineer of record or an end user, is super, super critical because building trust, there's so many microgrid providers and battery energy storage system providers and people out there right now that it can be difficult to kind of weed out who's going to be here next year versus who's going to be here 15 years from now and working with a trusted partner. So being a trusted advisor and an educator is something, even when I was in the more technical hands-on side of the world, every single project I was involved in at one point or another, I was finding myself being a teacher. So being able to speak the language, know the main concepts and things will go a very, very long way in terms of developing those relationships, identifying projects, and so forth. So there's a lot of really good resources out there, whether you just do a Google search. I know Steiner has some good resources on their website, as well as on the Schneider website too. And I'm happy to send some other information over, some nighttime reading material, if you will, Rob, if you want to disseminate with
Sure.
the audience here. But if I say one thing, just do some further education because, like you said, it's a rapidly everyday changing market.
Yeah, and just with that as well, as we kind of close out here, one of the things is Steiner has 4 people on staff. here to kind of help you navigate that, and dealing with your solar, with the battery, with all these alternative energy sources, as well as how does that integrate to your existing power distribution equipment and in alignment with Steiner. So we have some experts here that you can start with just to begin to have a conversation. And to your point, start the journey and the research, so to speak, of, hey, this is what my one line looks like. Where should I even begin? Right.
Yep.
So thankfully we have 4 people between Wes, Tom, Medea, and Joyce on staff ready to go to kind of help you navigate through that. Maybe I feel like maybe we can possibly have you on another one. We'll call it part 2 of
I would love
Microgrids to kind of
As you
dive
can tell,
into
guys,
some.
I'm passionate about this stuff. I love talking about it. I'd be more than happy to, Rob.
Yeah, no, I think it warrants that we did the introduction and that we should probably have a part 2. But very much thank you for the time today, Billy. Appreciate all the insights and the passion that you have towards this, because I mean, it's changing the dynamics of how we use energy. I'm not going to say electricity anymore, but it's really about how we consume energy, not only in our business, but I can see this blending into our personal lives as well.
Yeah.
And understanding as EV and battery storage and solar all come into play all together. And we need to be educated as consumers, not only on the business, but our personal side as well. So this is a very relevant topic and very educational for a lot of us. So with that, I thank you very much. I wish we had more, but I think I'm going to have you back for part 2 to go to the other slides. But I will say, coming up in September, shameless plug, we're going to talk about fall protection with a supplier of PIP, and really kind of what does that need, and where do you have it? What are the OSHA requirements for that? Because that's just as important. And we think kind of related to this today, where a lot of these products are housed and where they could be housed, it's important as people go up and work on that they have fall protection to keep them safe as well. So with that, I appreciate the conversation, Billy, and we will have you back on for a part 2 and do even a more deeper dive after that.
Yes, sir. Thank you, Rob, and thank you everyone in the audience. Really appreciate it, guys. Thanks for the opportunity.
Yeah, it didn't look like we had any questions. So with that, we'll leave it and we'll talk to you soon.
See you guys.
All right, thanks.